dy by dx. What is the meaning of this? We know gradient d by dx of y. D by dx of y. This d means differentiate or derivate. Okay, in other words, derivate. So differentiate of y. Y means f of x. Y means f of x. This is the meaning with respect to x. D by dx of fx means d means differentiate, dx means with respect to x, function of x. So we can get another function. So we are calling that function is f dash x. So this is the differential operator. This is one operator. So this is expect only the function of fx. This is expect because of this is respected to x. So this operator need one function that is in terms of x. Then only that one will give the answer f dash x. If you are giving another function, for example, d by dx of sine theta, so you never get the answer. You can't get the answer because of this operator not change. Operator not work. That is not give the answer because of this is expect function of x. If we are giving another function, then we have to do function of function. Later we can study. Okay, so this operator won't work. Right. So this f dash x dy by dx. Now we are studying dy by dx means d by dx of fx, d by dx of, in place of y we can put fx. This is we can write limit of delta x tends to 0, delta y over delta x. In place of delta y, we can write f of x plus delta x minus fx. So limit of delta x tends to 0, in place of delta y, f of x plus delta x, minus f of x over delta x. So this is called f dash x. So hereafter, if we come across this function, we can denote in place of that f dash x. What is the meaning of f dash x? Differentiation of fx at any point. So dy by dx, f dash x, limit of delta y by delta x tends to 0, or limit of delta x tends to 0, function of x plus delta x minus function of x over delta x. These all same meaning, that is equal to gradient of tangent. At any point P. If we need dy by dx, at particular point x is equal to x naught, then we have to substitute any one of this place. So you can put f dash x naught. This is one number. That number is equal to gradient of the graph at x is equal to x. So if you come across like this, limit of delta x tends to 0, limit of delta x tends to 0, another function g of x plus delta x minus g of x over delta x. If you come across like this, limit of delta x tends to 0, g of x plus delta x minus g of x over delta x. This is you can write g dash x. What is the meaning of g dash x? The gradient of the tangent at any point of function gx. Okay? Right. So now we will find dy by dx for any function. So what is the formula for dy by dx? The formula for dy by dx dy by dx is equal to limit of delta x tends to 0, function of x plus delta x minus function of x over delta x. So hereafter, if we want to find any function derivative, we will apply this formula. So if you apply this formula, then that method is called first principle. So finding dy by dx from first principle. For example, so we will find differentiation of x. Differentiation of, this is the first theorem, d by dx of x is equal to, what is the answer? d by dx of x. So we can say the function is f of x is equal to x. So from this, f of x plus delta x. So here after no need to draw graph. Any function if they are giving, we have to apply this formula. dy by dx, the first principle formula, dy by dx, limit of delta x tends to 0, function of x plus delta x minus function of x over delta x. We have to apply this formula. So the given function is x. So we can call that is f of x. From this, f of x plus delta x. How do you find f of x plus delta x? In place of x, you have to put x plus delta x. Then you can get x plus delta x. So we need dy by dx. So dy by dx of fx. Or otherwise dy by dx. Y is equal to x. The given function is y is equal to x. Y is equal to x. So according to the definition, according to the formula, limit of delta x tends to 0, f of x plus delta x minus f of x over delta x. Okay, limit of f of x plus delta x minus f of x over delta x. So this is equal to limit of delta x tends to 0. What is f of x plus delta x? X plus delta x. So x plus delta x minus x over delta x. X plus delta x minus x over delta x. So that is, so dy by dx or d by dx of fx or d by dx of fx is x is equal to x plus delta x minus x, then x cancel, then you will get limit of delta x tends to 0, delta x over delta x. So delta x over delta x 1, therefore limit of delta x tends to 0 of 1. So 1 independent of delta x, therefore delta x tends to 0, not effect to this 1, therefore answer is 1. So finally, what is the conclusion? The differentiation of x or derivative of x is equal to 1. So this is the final result. So hereafter, if we come across any places differentiation of x, then we can substitute in place of that 1. So now we have the first answer or first conclusion, d by dx of x, first result is equal to 1. What is the differentiation of constant? What is the differentiation of constant? So any number, if you differentiate, what you will get? So if we come across d by dx of 5, d by dx of 5 is equal to, what is the result? D by dx of 7, what is the result? Yeah, 9. So we will call y is equal to k. There is a constant k, y is equal to k. So this k you can write k into x to the power naught, any number to the power naught, expect 0, 0 to the power 0 undefined, indeterminate. So if any number, this is k into 1, we can say this is k is equal to k into 1. So in place of 1, we can write k into x to the power naught. So fx is kx to the power naught. And other formula, so d by dx of kfx, so not in proof, d by dx of kfx, that is the proof came from limits. So d by dx of kfx, you can write k d by dx of fx. You can take out the constant. So we can apply this one also here. So f of x is equal to kx to the power naught. So f of x plus delta x. F of x plus delta x is equal to k times x plus delta x to the power naught. So now we have to find dy by dx or d by dx of x to the power naught. So according to the definition, dy by dx is equal to limit of delta x tends to 0, f of x plus delta x minus f of x over delta x. Okay, this is limit of delta x tends to 0, f of x plus delta x. We can put this. So k times x plus delta x to the power naught minus k times x to the power naught. So we know over delta x. So we know k x to the power naught is k. X plus delta x to the power naught 1. Therefore this is also k. Then we can write, so k minus k, limit of delta x tends to 0 over delta x. K minus k is 0. 0 divided by any quantity, 0. So limit of delta x tends to 0 of 0. The 0 independent of delta x. Therefore this is not equal to this answer. Therefore finally answer is 0. So what is the conclusion? So d by dx derivative with respect to x of one constant is equal to 0. So hereafter if we come across any results for the differentiation of constant, then you have to write in place of that 0. So d by dx of number is equal to 0. So sometimes you will come across d by dx of 0. So that is also one number. So you can write 0. Okay? Any problem? No. So now we will move to y is equal to x squared. Y is equal to x squared.